Okay, I'll get started. Hi, everyone. Today, we are going to be talking about CAP 75, which is a proposal to add two new host functions to support Poseidon and Poseidon2 hash functions. So the CAP itself is fairly straightforward. Two new host functions. It's pretty standalone, doesn't involve any of the previous protocols mostly, except using the BLS and BN field. But I want to spend a little bit time on the approaches that we decided on and the rationale behind this approach. So first of all, just a quick introduction on the motivation. Why do we want the Poseidon and Poseidon2 hatches? So the Poseidon and Poseidon2, I'll call them Poseidon family. So they are a family of hashes. Basically, it accepts a range of parameters, and then you can configure it to compute output. So what it is it's a sponge-based hash function, which means it consists of a sponge that absorbs input and spits out output, which is a variable length input, variable length output function. And internally, there's a permutation, which is fixed input, fixed output. And the reason that it is useful, along with other hashes of similar design, is that it directly operates natively on the prime field. And as you note, most of the zero knowledge applications are built off of the prime field, such as BLS or BN254, which makes Poseidon natively work with this field, and they are ideal in DK application. Just to give a rough idea, the amount of constraints to generate using a regular hash like a SHA-256 versus Poseidon is 2 orders of magnitude difference. So it's a lot of proof site, less proof site complexity and time to use Poseidon. So for contrast, the proof verification typically don't involve rehashing or anything. But for contract implementing logic, such as a Merkle tree that you want to generate proof of, you want to have the same hash implementation between your contract and what you use when you generate the proof for that Merkle tree. I think that's quite obvious. And to have the Poseidon implemented on the gas side or on a contract side, it's quite expensive. Even with the functions that we already provide for BLS field arithmetics, there's still a lot of round trips between converting a few elements to bytes and things like that. So that's why we want to support Poseidon as native host functions. So just a recap of where we were last time. Last time we proposed three possible approaches to this. First is just to provide the hash functions, plain and simple. For different fields, for different field, combination of B and BLS, combination of Poseidon, Poseidon2, and a combination of number of hash input. So this gives us like 8 different type of host functions that will cover a lot of use cases. But this approach isn't good because we've, from the feedback and from the evidence, that a lot of these hashes, they require particular parameters. These parameters are not set in stone. So different implementations could choose them differently. So even if we specify them in the host, for example, someone else might need a different way to provide the parameter. So this way isn't just provide a hash function isn't the most maintainable way. And what about providing more host functions for those field arithmetics? And also, it wouldn't solve the problem because even if we provide things like matrix multiplication, the Poseidon hash involves a lot of rounds of permutation. Each round is doing this multiplication. So we still end up with a lot of these calls and a lot of these round trips. So one of the proposals ended up last time was, can we provide a more generic interface for the sponge hash, namely to absorb some input doing permutation and spit out the output, and then let it be parameterized. So yeah, so that's what we settled on last time, and yeah. So now to transition to this cap. So this cap proposes a slightly different approach, which I call approach 4. That's on the discussion thread for anyone who's following. So approach 4 is, instead of providing the sponge interface, we provide the internal permutation function that the sponge hash uses. So why is that? So the sponge is it's sort of its own animal. It's a different animal than the permutation. The sponge design has many different considerations for different applications. For example, not only for hashing, but also for generating like a random stream of bytes, or for message authentication code, or for random for reseedable random value generator. Like, these applications are all design scope of a sponge. So the sponge needs to be more flexible. It needs to maintain a state. It needs to, in some cases, it requires switching between absorbing and squeezing, and then switching back. So the sponge interface itself isn't a single definition that we can just take, because and itself also has some complexity in it. However, internally, all the sponge functions, they call the same permutation function. So in both sponge absorb and squeeze, the input and output, before it was the input is passed, and then the permutation is applied, and the permutation is applied, and the output is squeezed. So at the center of it is just this permutation function that takes a fixed length input and a fixed length output. So this is much more maintainable, and it's much more easy to support in Soroban without ramifications, because it's just a simple cryptographic building block. And the Soroban host doesn't need to maintain any state. So there's no like state-related issues for, like, what if you make a subcontract call? Do they reinitialize the sponge, and how to do that? So by supporting Poseidon permutation instead of the 4 Poseidon hash, it gives us a lot of flexibility maintaining a Soroban host. And also, sponge itself, for a simple hash algorithm that's like a binary hashing of a Merkle node, for example, isn't that complicated. It's just a single round of taking the input and applying the permutation and spitting out the output. I've written down a little pseudocode that basically is what it is in the cap. So just to recap, the sponge interface is complicated. The sponge is designed for many different use cases, not just hash. Even though for hash, the sponge is really simple, we don't want to just bake in a simple sponge implementation inside the Soroban host. While this is much easier to do it in the contract or in the guest or in the SDK. But it makes much more sense to support the primitive that's mostly the most expensive operations happen, which is the permutation function inside the Soroban host. So that's a high-level motivation. And now I can go through the actual 2 functions being proposed. One is a Poseidon permutation, and second one is Poseidon2 permutation. The 2 look fairly fairly similar. So just a bit of background. Poseidon is the original version developed in 2019. Poseidon 2 is a improved version of that developed in 2023. Internally, they work slightly different. Poseidon 2 has improved the internal matrix shapes and then add some pre-application, add a single layer of pre-apply. But overall, it works fairly similar. So I'll just cover the Poseidon one. So the Poseidon permutation takes the input, which is a vector object, that is your vector of field element. And then the second thing is the field type. So I think it probably makes sense to have field type as a symbol, but in the cap, I'm putting U32, should be equivalent. But yeah, field basically is the enum that specify which field you want your permutation function to be defined on, and of course your input will be passed in the same field as the permutation matrix and all that. And the rest of it is just internal parameters for the hash function. So that's pretty much it. But I'll just spend maybe a couple minutes just explaining what these fields are. T is the capacity parameter, so it's the capacity, the internal, sorry, not the capacity, but the internal state size. So internal state size must match the input, and also must match the size of the internal matrix. It is decomposed of the rate, which is number of, you can think of as number of input you need to hash at once, plus some capacity, which gives you additional security parameters. D is the degree of the S box, which is the internal, one of the internal step in the permutation before applying the matrix multiplication. So for Bn and BLS, both fields, D is equal to 5. So we may just only accept D equals 5. But of course, for other fields in the future, this D could be different. The round F, round P, these are the internal partial rounds and the full rounds. These are the number of rounds the matrix multiplication happens. There's also a linear layer, which is the linear layer is around the matrix multiplication, but the nonlinearity is provided by the round constants, which is also matrix but specified for each round. So the MDS matrix for hash2 function is 3 by 3. Round constant is another matrix with dimension n by m, where n is the number of rounds and m is 3. So that's a high level run through of the different parameters. The second one is fairly similar. The only difference is that the internal MDS matrix in the second version is a diagonal matrix because of the Poseidon2 improvement. In terms of cost types, so we manage, I think we can manage to ship this as a native Soroban library, which means that all of the operations, they are already existing and were defined. These include the field arithmetic for adding and the multiplication and things like that. So there's no particular Poseidon specific metering parameters we need to support, but we do have to add these BN254 field arithmetic cost types, which is a very opportune timing because we have the cap74, which adds BN254 scalar field and pairing. So I went through the parameters, metering, rationale. Yes, so that the rationale why hash function, why we don't provide a hash function out of box rather than providing the permutation primitive is explained. And yeah, just to also mention these parameters, they are, so Yeah, so some of them they are kind of defined based on the application. Like if you have a curve of if you want to do hashing with BN254, then the degree is 5. You can change that, and then but some of them is depend on the actual application, which is how many inputs you want to hash at once, and then based on the size of the input, these parameters like t and then the number of rounds, they need to be adjusted. The original Poseidon paper provides scripts and guidelines for how to generate these parameters. In general, I think most applications have their own. They use a set of generated parameters like Circom does and Noel does, and to provide the maximum like safetiness, we would have these as part of preset in the SDK. So like the SDK interface will look exactly just like a hash tool that takes 2 input, and then internally you may be able to specify the set of parameter like a circum parameter or null parameter, things like that. And then we will also possibly expose these Poseidon permutation as a more like a hazemat interface, something that advanced users that know what they're doing can call with their own parameters. But we will make them the distinction more clear. Yeah, in terms of testing, so there's a reference implementation for Poseidon and so Horizon Lab has a reference implementation for Poseidon2, and in the same repo has Poseidon1. That's the one we're likely going to adopt, and it also provides test vectors for both 1 and 2 in different fields and parameter. And then there's also the original Poseidon paper that come with a Sage script implementation with some reference vectors, which we will also match our implementation with in our tests. There's a draft implementation, and I think that's it. Now floor is open for questions. Yeah, so I did a very rough, well, I wouldn't say too rough, but like the implementation is fairly mostly good, and then the field for BRS is already there. So I did a number on the reference test cases for BRS. The 3x3 matrix case, which is the hash 2 operation, that's about 500,000 CPU instruction. So it's a lot better than what I projected last time. And then the 5x5 matrix case, I believe that's like hash 3 input. That's around 1 million CPU. So yeah, that's well below our target ceiling, which we want to support around 20 hash cores in a single contract. answer questions. Okay, back to you, Carsten. Oh, okay, you want me to close it? Okay. Bye, everyone.